Aloha! You're watching F5 Web Media on Demand. I'm Peter Silva, Technical Marketing Manager with F5, and we've been hanging out at the RSA conference all week here in San Francisco. And I now have the distinct honor of interviewing Dan Kaminsky. He's the Director of Penetration Testing at IOActive. Thanks for joining us today.
It's great to be here.
Nice to see you. I'm kind of a little giddy to meet you, finally.
Yeah, good times.
And so can you tell us a little bit about IOActive and your role there?
Yeah. I'm the Director of Penetration Testing for IOActive. So I run the hacking group. We have a lot of top-flight security engineers. No checkboxes. We just break stuff. It's what we do. I mean, there are people who want checkboxes, there are people who want stuff broken. If you want stuff broken, come talk to us.
Beautiful.
We do the entire range from web attacks to hardware engineering. We actually been doing a lot of work with Smart Grid to make sure that the power supply for the world is actually secure. So we have a wide range of skills. We were one of the major vendors for the Microsoft Windows Vista project and other of their operating systems. So we came in and worked with them to help them deliver a secure product to the masses.
And I believe you've worked on a few of our products a lot over the years, testing them and such, yeah?
See, you're allowed to say it. I have to be very circumspect. It's just,
Right. And so within the last year, you've been actually credited with finding a major vulnerability with the domain name system infrastructure, the DNS cache poisoning vulnerability. And it's actually named after you. Kind of cool.
The funny thing was, I figured if I didn't give it a name, people would focus on what I was actually proud of, which was getting it fixed. I was joking, I was calling it massive multi-vendor security remediation. And instead people called it the Kaminsky bug. I'm like, that didn't work out like I thought it would. Crap.
So those who might not be unaware of what that exactly is, what is DNS cache poisoning?
All right. Well, the way the internet works is, it's like the phone network. You don't put a name into your telephone. If you want to give someone a call, you have to put in a number. Mm-hmm. But there's a difference between the way the internet has numbers and your telephone has numbers. I'm from San Francisco, and my family has had the same phone number for 30 years. Mm-hmm. You know what? I have not had the same IP address for 30 years. Often I won't have the same IP address for 30 minutes.
Sure. So
because numbers move so quickly, we have a directory system. It's like 411 for the internet. But you just always consult it. You consult it all the time. It's very fast. It's very automated. It's called the Domain Name System, or DNS. And the interesting thing about DNS is it's one system with a kind of a centralized root, but it delegates. So, Google gets its space, and Microsoft gets its space, and Yahoo gets its space, and they can manage their own portion of the world. But if Google needs to find Yahoo's mail server, say, hey, DNS, where's Yahoo's mail server? And it gets an answer. Or Yahoo can say, hey, where's Microsoft's mail server? It gets an answer. And it's not like these companies had to make any prior arrangements or deals or corporate complexity. It's just ask, and an answer comes back. And so it's a very nice system where delegated control exists, but everyone can, find whatever information they need to make their protocols function. Right. And so, at the end of the day, DNS is at the heart of why organizations are allowed to speak to each other. It is the cross-organizational glue that ultimately every database, every mail server, every web browser, everything ultimately comes back to DNS when they need to find, where is that other guy anyway?
Right. So it's very critical, obviously, to the survival of the internet. And you ask local. And if local doesn't know, you ask ISP. And if ISP doesn't know, then it goes ask root. If root knows if it's a .com, it says go ask TLD, the top-level domains. Top-level domain says, oh, I know where it is. You go ask this guy.
It's a way of bouncing around till you get the right answer with the actual reasonable amount of trustworthiness.
Right.
The funny thing is before, there, on the one hand, it works. On the other hand, it works securely. And if it's between works and works securely. Like if it works securely, but it normally doesn't work, people won't deploy it.
Right.
So generally, it's very fun. I've stood in a room and I've said to 100 engineers, how many of you think you depend on DNS? 2 hands go up. Now I say, How many of you, anywhere in your products, have somewhere where you put in a host name of some machine you need to speak to, and 100 hands go up, and I go, where do you think that IP address comes from? And I go, oh.
It's funny.
It's really funny. Like, people underestimate this thing, but to be fair, it works so well that, I mean, look at this one. The things that make the DNS ultimately work are these things called root servers. And there are 13 of them that are distributed around the globe, these organizationally. And these 13 servers were there 20 years ago. Right? These 13 servers will be there 20 years from now. You tell me what else on the internet could possibly have a 40-year window of existence. I tell you there's nothing. So that is why so many things have ultimately used DNS as a foundational technology to allow themselves to function.
And because it works so well, sometimes we often forget, right? And that happens in a lot of things, right? Because certain things work so well, you often forget the criticality of it and the importance of it.
The squeaky wheel gets the oil, man.
Yeah.
Things that break a lot, you go, okay, I know about this because it breaks a lot. The things that are just quietly working, just assumes that can't be the problem. Right. And so one of the funny things that we've seen happen is people tend not to firewall or otherwise manipulate DNS because when it breaks, nobody knows how to debug it. If some other system breaks somewhere, and they're like, wait a second, what is going on here? And they'll spend 15, 20, 100 hours to find out the problem. And then, only then, do they trace it back to the guy who messed with DNS.
Right.
So that guy who messed with DNS now has 100 hours of pain in somewhere else in the organization to account for. And that's why ultimately no one messes with the protocol. They just leave it there. They hope it never breaks. And it's like there's a little tiny corner that everything depends on.
And so with all those answers that are already out there, and many of them cached, with DNS cache poisoning, that then allows somebody who's not authorized or somebody to step in the middle of the request and redirect that to, say, a malicious server or their own.
Exactly. I mean, a simple model of cache poisoning might be, you think you're going to Google, but that's not Google. You think you're going to the bank, but that's not your bank. Where things got fascinating once I started really digging into cache poisoning was when I started looking at the web and the way the web does authentication. So you have a username, you have a password, but because you're a human being, you forget stuff. So every major website has a forgot my password button. So how does this thing work? Well, it sends you an email, and you have to click on the link and go ahead and say, yeah, it's me. So it sends you an email. How does it know how to send you that email? Well, it looks it up and, oh, that's right, DNS.
Yes.
So if I control DNS for a website, I control mail for a website. I control mail for a website. I can log in and get administrator credentials on that website.
That's where it turns scary.
And that's when you start realizing, wait a second, this little piece, this cross-organizational glue we've been depending on, oh my God, like, it will just get you into everything. It is shockingly a skeleton key.
Right.
Now the funny thing is, when I found this bug, I knew it was bad. Like, I knew it was a problem. But I figured, well, everyone knows DNS is important. I don't need to, teach people this. I mean, give me a break. And I got some very interesting feedback, like, oh, come on, DNS can't be that important. I'm like, well, looks like I got some work to do. And, by the time I finished out that deck, I mean, people were like, wow, we sure have a lot built on that deck of cards, don't we?
Yeah. And I still have that. I downloaded it the day it became available and read through it. It's really interesting. So next week, there's a webinar coming up for DNSSEC. It's yourself, Cricket Lou with Infoblox. It's a combined effort with F5 Networks and Infoblox hosting this webinar. Yourself, Cricket, Scott Rose with NIST, and our own Nathan Mara, product manager for Global Traffic Manager. So when we were talking a couple of days ago, you were like, nobody knows about DNSSEC. I can't believe it. So for our viewers who might not know, what is DNSSEC and its importance to kind of maybe the survival, if you will, of the internet?
Well, so this is what's very interesting. I have to be fully honest here. I was not a DNSSEC supporter at all. I was like, no, this is this technology. We've been working on it for a decade. The engineering has been a train wreck, blah, blah, blah. I mean, I'm saying these bad things because I need the audience to understand this has been a 180. Like, me being a DNSSEC supporter, here's what happened. So we find this bug, right? And I get a summit at Microsoft, and we've got all these people there, and a fair number of them have been pushing DNSSEC for a decade as the canonical fix for this class of problems. Mm-hmm. I say to them, guys, I like all of you. You know I believe in all of you. You've been trying to do this for 10 years. We're not going to do it in the next 6 months. Dan Bernstein came up with the right fix for now, for what we need to do. Let's do his fix. If you do it, I promise, I will give DNSSEC a fair and honest evaluation. I will really think about it and really work on it. But please, let's do what Dan Bernstein said. And people said, okay, do this approach. It's the right approach, engineering-wise. We will be able to deliver Dan Bernstein's solution. DNSSEC will look at after. So we put in Dan Bernstein's fix, and that's been a great stopgap. It's been a great Band-Aid, but nobody thinks it's a complete fix. Sure. At the end of the day, we made my attack 65,000 times harder. That's nice, but now it's 650,000 seconds.
And his solution specifically was to address specifically what you had found.
His solution was the great thing about beautiful design fixes is they address bugs that you don't even know. It's, you know what, I'm looking at this and this piece right here, it's wrong. And I'm pretty sure something bad is going to happen. Dan Bernstein didn't know about my personal attack, which was TTL bypass through alternate names. The details don't matter. It's an old bug. But Dan Bernstein's solution, which was to eliminate the entire class of potentially malicious replies by increasing the entropy from 1 out of 65,000 to 1 out of a couple billion, this was great engineering, and his advice should have been followed. And there was this, everyone gasping moment at the summit when Paul Bixby just said, we should have done what Dan Bernstein said 10 years ago. So everyone's like, man, if Paul's going to say it, okay, let's just do it. But the summit gets out, we get the patch out, deal with it all, and I start looking at DNSSEC. And I realize a couple things. First off, it does actually utterly address my bug. Forget 1 out of 65, 1 out of a couple billion. The work effort of breaking the cryptography is sufficiently high. It is a much more solid, much more canonical fix. Right. This is wonderful. But perhaps overkill. All DNSSEC did was fix up addresses. Now maybe there'd be easier ways. I'm just saying it's true. But then I started looking at the state of security in general. And let me tell you, I can send an email to Yahoo. I can send an email to Microsoft. I can send an email to Google. But I can't encrypt an email to any of these companies. Why is that? Why is it so much easier for me to get connectivity cross-organizationally than it is for me to get authentication and confidentiality cross-organizationally? And the answer is because DNS gives me where to go, but not how to recognize who I'm speaking to when I get there. The secret of DNS is it's like HTTP. HTTP was designed for flat web pages that lived on a file system. You ask for the file, you get the file. And maybe every once in a while you hit a CGI script. And that's not how we use the web anymore. The web is a totally different beast because we've realized we can be radically smarter, radically more intelligent. And you know what? It's our space. We can do whatever we want in our space. You know what I want to do? I want to publish encryption keys for my website, for my email server, for my IPsec endpoints. I want to stop buying products that work very well in the lab, that maybe, if I'm lucky, work very well inside my division or organization, but fall on their face cross-organizationally because they don't use the only technology in the world that works well cross-organizationally. So DNSSEC is significant because finally, after all these years, we're going to have a good way to authenticate people in other companies. It is going to fix our auth bugs.
Wow. Yeah. And so essentially, in the simplest form, right, DNSSEC will sign. So when you go request yahoo.com, google.com, it goes back to the authoritative server, wherever that may be. And when it returns the answer, it digitally signs that answer and goes back so that you know it's authentic.
Exactly. So anything I need, any basic, think of DNS as the bootstrapping engine. It tells you what server to go to. It can also tell you what to expect. Who is this person? What are their keys? What is the configuration you're supposed to use? What is the other server maybe you need to talk to?
Right.
It's not my place to tell you what to put into your DNS. It's your DNS.
Sure.
But right now, you have no way to securely publish this stuff. We keep pretending we do, and it's a buggy. It's a horse buggy, and we need race cars, man. We need some race cars. And so the thing that I've been incredibly happy about has been when this all hit. All the guys who had been pushing DNSSEC, who had really been carrying the torch, Scott Rose in particular, Doug Mon from DHS also. These are guys who've been suffering for years, knowing cache poisoning would just take everything out.
Right.
Believe me, I was not the first to figure that one out. Probably wasn't the first to find this bug. I just wanted to be the last. My best I can tell, a lot of people are like, we told you. You should do this one thing that DNSSEC needs that comes from the political side of the universe, which is there is a root. There is a root that is at the heart of making DNS work. And it needs signatures too. Right. You cannot efficiently and scalably do DNSSEC without the root being signed. They kept trying. They spent a whole bunch of time and energy seeing if they could figure out a way. But DNS needs its root. It needs it. It's just how it is. It's why it works. It's the magic sauce. And after I found out that the root was going to get signed, because of all of these guys worked for 10 years, maybe a little bit of me, okay, this can happen. We are going to have a single root. We are going to have the ability to do this work. The market is going to start responding to this. Yeah. We are going to finally see, I got to be honest, a lot of DNSSEC tools out there, a lot of DNSSEC servers out there have been not the easiest to deploy. Sure. And because all of this has happened, now there can be return on investors. Now, all these companies that have had all these products that haven't been scaling, they can say, wait, we can take this path. We have the new widget. It's like the fork was just invented, and all we were using was spoons. And the thing that
don't bash the spoon, man. Cereal.
Cereal is great, but sometimes you want some steak, man.
Yeah. Okay. Fair enough.
You ever try to eat steak with a spoon? Doesn't work. Maybe a spork. So what's been so great and so satisfying has been seeing company after company coming on board and really doing the back-end work if they're a service provider and doing the product work, like if they're F5, to make DNSSEC work not merely from a theoretical perspective, not even from just a specification perspective, but we have a real world with real networks that are really huge. Right. And we've had to do some strange things to make them work. And it is great seeing DNSSEC morphed into what the real world needs. Right. See, the biggest conclusion from my research in DNSSEC, the thing that blew me away and flipped me around 180, is present implementations are crap. There's no arguing about that. We know it's true. Man, it's like JavaScript. Inside all this crap is actually a really nice system. And as soon as the forces are there to allow this system to be exposed, we're going to see that diamond come out. And that's what we're seeing. It's great.
Cool. That's great stuff. And so how has, by, kind of discovering this very significant vulnerability, within the internet at large, has it changed your life any? Are you kind of, sort of a celebrity within the space or something now?
And it didn't set out to become a controversy. I just played with toys.
I know.
It's, you know what? any situation you get into, there are going to be headaches. But at the end of the day, I found myself being able to be in positions where I can make the internet a safer place. And that's all I wanted.
And I think, I guess, more I was maybe driving along the lines of not people believing you, if you will, but there more credence to the types of things that you have been kind of preaching and saying and propagating, over the years. There's no more what are you talking about, Dan? That's crazy.
Well, there are a couple of things that I'm very happy about. One thing I'm very happy about is nobody says man-in-the-middle attacks are just theoretical.
Mm-hmm.
I mean, it really used to be, there are a whole bunch of attacks that you can only do if you are interposed between a client and a server. You have to be the middle guy, you have to be who we call Mallory. And for years and years and years, people are like, yeah, but you'd have to do like DNS cache poisoning. Well, gotcha. and this is great because so many really good bugs are now getting credibility. Moxie Marlin Spike found some great stuff against SSL. Marsh Ray found the issue with SSL renegotiation. All of these things, there are entire class of bugs that people were poo-pooing by saying, yeah, but you'd have to be in the middle. Now it's very clear you can be in the middle. That might happen, right. And the protocol has to survive that because that's why we're encrypting, because we assume there's a bad guy. You don't get to say you're secure unless there's a bad guy.
Sure.
Like, come on.
Right.
So that's kind of cool as a side effect.
And those you've mentioned are all very recent, kind of, that they've been put out and show how to do it. And people are like, I believe.
Yeah, to the extent that it's possible, if my research can make legitimate, very cool, very smart work have an easier time in the public discussion, I think that's great. I'm very happy about that. I am incredibly pleased to be able to support inter-vendor collaboration. I mean, let's be honest, security is so much bigger than any one company. And I was so proud to have all those companies come to Microsoft. Let me tell you, these aren't all people who have any love of those guys. But you know what? They came. Because it was the right thing to do, and everyone would benefit. And I want to see so much of that. I want to see companies coming together, synchronizing their operations, synchronizing their fixes, so that customers, our customers, the people who pay our way, have a clear message from the industry. Okay, there might be a problem, but here's your actions, here's your fixes, here's what you need. And that level of communication, I mean, that's what I see as the big success. You know what? I found a bug. Hey, guess what? It took a day of chatting with a buddy about content distribution networks and a couple days of poking at the protocol. It was 6 months of work to get it fixed. And I think the way the fix happened has really shown, hey, if we all work together, we're all going to benefit.
Right. And really, ultimately, right? You've really helped that far end user. Ultimately, just all of the people, all of the consumers out there that are connecting to the internet that don't have the technical knowledge that you or I have. They're the one you might click on phishing scams or not understand the little lock in the bottom. But it's ultimately helping those people make the internet safer.
I gotta say, it was a moment of pride when my mom clicked the DNS tester and she was safe.
Yeah, that's what I mean.
How else does that happen?
Right.
So, it was actually, I should mention this. At the last minute, we're talking the last day or two, before we went public, I should put up a tester. I should put up a thing that an administrator can click on that says, your name server is safe or your name server has a problem. So I put this thing up, and I just assumed, this is a nice service to administrators. Well, what happened was, not only did the administrators click the button, the users clicked the button. They're like, hey, I want security. Why don't I have it? This thing says I don't have it. And all of a sudden, there was clear, oh my God, there's demand. People care. Right? And granted, maybe this wasn't as perfect as it could have been. It was a little inconvenient to some people, but I was very pleased to see that there were actually a lot of people who were like, I want to have a safe browsing experience. I want to have safe networking. can't manage what you can't measure. People can measure incoming emails. People can manage incoming phone calls. We gave people the tools to know there was a problem, so users had an action. We gave people the tools so that they could fix the problem. Can you imagine how awful it would have been if I had released a tester and hadn't got the fixes out?
Yeah.
Like, what am I? You're an admin. You're an assistant. What are you supposed to do?
Right. Yeah.
The only thing that I couldn't do, and I didn't even know this was going to be as much of a problem, but it was huge. It was like the defining pain. Administrators didn't come back to me and say, "Why do I have to patch?" You know what they said? Man, I don't even know what name servers I'm running. People don't know what's in their infrastructure. These things grow organically, and the only thing we have modern and skilled operations for patching are for desktops, because desktops got their butts kicked. Yeah. When infrastructure goes bad, our institutional knowledge for dealing with that is so tiny. Let me tell you, the bulk of it.
Yeah. Wow, that's very interesting stuff. Very cool. So if you want to learn more about DNS and DNSSEC and hear more from Dan and the rest of the DNS experts like Cricket and Scott with NIST and our own Nathan Meyer, please join us for the F5 Networks and Infoblox webinar. It's next Wednesday, March 10th, 11 o'clock Eastern, 8 a.m. Pacific, and 6 a.m. Hawaiian time. You can sign up for the webinar either on the Infoblox website or the F5 Networks website, www.f5.com or www.infoblox.com. It's been great talking to you. Thank you so much for joining us.
Glad to be here.
Great.
Thanks, guys.
You've been watching F5 Networks Web Media on Demand. For Dan, I'm Peter Silva. Thanks for watching. Hey, so, where'd it go? You're not here,
Really? Okay. There you go.
All right.
Good times.
Yeah. And we're out. That was awesome.
That's freaking cool. I am so happy to hear about the product. That's great. Get it immediately.
Yeah. So that was the secret sort of special sauce that we've figured out.
Excellent. Yes, it is a piece that needs to be dealt with.